Now we're going to continue with another example where we use the substitution method to solve a system. And the system we have here is 1/2 x plus 1/3 y is equal to negative 1/3. And 1/2 x plus 2y is equal to negative 7. Now I think I can almost hear some of you hyperventilating because you see all those fractions in there and you think, oh my gosh, how complex this is going to be. Well, the good news is we can make the system simpler by eliminating the fractions before we proceed. So let's do that. And what we'll do then is to multiply the first equation here by 6, which is the LCD of the fractions in the equation. And we'll multiply the second equation here then by 2. And so when we do that, we'll end up with the first equation turning into then 3x plus 2y is equal to negative 2. And the second equation will simplify to x plus 4y is equal to negative 14. So now we can rest a bit easier because we've eliminated the fractions. Now at this point, I think it's probably pretty clear the best choice for solving for one of the variables would be the second equation, where we would solve it for x, because solving for any of the other variables in either equation would result in some fractions, which of course we don't like. So let's solve this equation now for x. So x then would be equal to negative 14 minus 4y. And what we'll do then next is substitute that value for x in the first equation. So we'll do that next. Now continuing, what we're going to do is to take this expression for x that we just found, and we're going to substitute it for x into the first equation. And we will then have, if we do that, 3 times the quantity negative 14 minus 4y plus 2y is equal to negative 2. And if we distribute it, we'll have negative 42 minus 12y plus 2y is equal to negative 2. We then have negative 42 minus 10y, negative 2. And if we add 42 to each member, we have negative 10y then is equal to 40, or y is equal to negative 4. So now what we'll do is find the value for x, and we're going to use the equation at the top to do that. So we have then x is equal to negative 14 minus 4 times negative 4. So it becomes negative 14 plus 16, or x will be equal to positive 2. So now we can state that the solution as an ordered pair will be then 2 comma negative 4. Now let's, to finish up, go through the check. We're going to take this ordered pair and substitute it into the first equation of the original system, and hopefully that will check out. So the original equation was 1/2 x plus 1/3 y is equal to negative 1/3. Now this is the first equation in the system, and what we'll do then is substitute 2 for the x and negative 4 for the y. And simplifying, we have then 1 plus negative 4/3. And getting common denominator, we have then 3/3 plus negative 4/3. And the left-hand side does simplify to negative 1/3. So we can see that that ordered pair does check in the first equation of the original system. And it would be really good practice for you to check that in the second equation of the original system.